Welcome to another session of Integrated Circuit Layout. Today we are going to look at design rules that are used in the layout of integrated circuit. What are these design rules? Why are they there? We'll look at them shortly. The design rules are a set of rules that represent the physical limits of a particular manufacturing process. Each the design rule would specify the geometric and connectivity restrictions um, in a semiconductor process. Now, these restrictions are necessary so that to ensure that after fabrication, most of the parts or most of the chips are working. Now, the semiconductor manufacturing process is not a precise process. There are lots, it is subject to lots of variances, as we will see shortly. Now, an example of the variance in the semiconductor process is shown here. Here you see that they are trying to create metal lines or fingers of metal lines which are of the same length and width. But as you can see very clearly that the width at this junction, at this point, is much thinner than the width at this point. So it is difficult to produce a uniform width in the semiconductor process. Similarly, if you look at you compare the five fingers, the ones on the inside tend to look more similar compared to the ones on the outside. So here we see the effects of the variance of in the semiconductor processes. Now imagine if the original lines were much thinner than this, and because of the variance in the semiconductor process, then at this point we would expect to see some breakage, and that may cause the chip not to function at all. Now let's look at what are the variances in the wafer fabrication process. There could be variations in photolithography. For example, there's mask misalignment. The photoresist shrink. For example, after you do a pre-bake, then there is the variations in the material deposition. When you deposit a layer of, let's say, polysilicon, the thickness of the polysilicon may not be uniform. This could result in a change in resistances and capacitances. You have variation in ion implantation. So as a result, your concentration in your active area, doping concentration in your active area may not be uniform. Variations in temperature. As a result of the variation in temperature, the diffusion depth of the dopants in the active area are not uniform. Variation in the doping concentration, again due to temperature, and that also could affect the resistivity or the capacitance if you're creating a resistor or capacitor. Then there's the variation in oxide thickness. It could result in non-planarity. That also can affect the capacitance, certain types of capacitors. And if you are building transistors, you need a very uniform gate oxide so as to control the threshold voltage. Now, the presence of impurities again could reduce the resistance in the conductors. And on top of all this variation in the process in a particular batch, you had have variations between lots. Because the substrate that are being used are different in each lot, the orientation of the wafers that have been placed are also different. The variations across a wafer, even within the same wafer, a die, let's say in the center and a die near the perimeter of the wafer, could have different uh, beha- produce circuits with different behavior. So all these variations, taking all these variations into account, the, we need to have a set of design rules so as to minimize the effects of these variations on the on the design process. So when doing layout, it's very important to follow the design rules as specified.